Hey everyone, today we're going to look at LeetCode 981 time-based key value store. So you can read out the problem. I'm directly going in the explanation. So let's see the example first. So in the example first, they have asked us, they have given these are the test cases. So we'll be having a time step, set and get, and we'll be having the time step at the initial in the first only, and after that we'll be getting the set and get. So in the set what we have been given, will be given the key, then the value and the timestamp for that particular, and we need to store it in some data structure such that we if we'll return it, I mean such that we'll be getting some values, we'll be putting some values and we need to figure out what will be the closest to them. So let's understand with the example. So we have been given this timestamp first. So this will be our initialization of our data structure. Then we have given the set. So in the set we have been given foo and bar. So we have I have put this foo here. This will be the first key, then then like this will be this is the value, this is another key I have put here, and then the bar will the value. So now they have asked us for foo of 1. So foo of 1 is the closest, I mean the closest thing to 1 is bar only. So for this one we have written bar, so hence for this one we have written bar. Then they are asking for foo3. So they are asking for foo3. So we have checked for foo3 there is no value. So what we'll do, we'll just go to the left side for this, because like they have asked if we have if the set was previously called with timestamp, we can return that one. So we can then call for foo of 2, and if that is also not present, we can call for foo of 1. Then we can see foo of 1 is present. So for foo of 3 also we are getting this bar. Then again we have another set variable. So let me add this one also. So it's bar 2 with value 4. So now if we'll call foo4, then we'll get this bar 2, and if call this foo5, then we will first check whether this 5 is present or not. If this is not present, we'll just decrement that value and see. So if we'll decrement, then we'll be getting foo, then foo4, and foo4 is already here. Foo, then 4, and we will be getting bar 2 for this. So for the last two values, we will be getting foo. So let's see some other example. So let's look in some other example, which is this one. And for this one, we have this is the key, and we have another set of value key and values in this particular map. So first we are asking for foo1. So we can see for foo1 it's bar. So we have written bar. For foo3 we have to return the closest to the left. So for foo3 it will be 3 first. Then we have to see the left side. So in the left side the closest thing is 1. So for this also we have written bar. If we have been given foo100, so for foo100 uh, it will be the closest thing. So this will return bar 3 here, bar 3 here, because the closest to the left for this foo is 8, and then for 1201 the closest thing to the left is bar 4, which we have returned. And we can have another thing also. For example, if we are this is some other example, and in this example we can see it's starting from 2 bar, then 4 bar, 8 bar, and 1200. So if we'll be getting foo1, so we can see it's not present in the left side, and we'll just return this empty variable for this. So I will be sharing three three approaches for this one. Let's look at the first approach. So in the first approach, what we are doing is like we have created an hash map with a hash map. Inside a hash map, we are having in a hash map, and in the timestamp we are just initializing the map. So for the set method, what we are doing is first we are checking whether we are having this key or not. For example, if we have been given this set as one then bar. So first we need to check whether we are having this foo or not. If it's not there, we'll just create a new hash map and we'll just add that particular value to it. Then this is the main part, which is the get part. So first I'm checking, like for example, if they have asked us for TOO1, so we can say to TOO1 is not here. So what we'll do, we'll just return an empty string for this one. Okay, so this is the first part. Then the second thing is we have to we have to find that element. So first of all, this what we will be doing, let's look from directly from here. So if we are getting, if we'll, for example, if we got foo3, so we can see, sorry, if we get foo1, so we can see we already have this value 1. Already have this key 1. So uh, it will directly return this one because like map that contains key, it will return true, and then we'll go into the else part and we'll just return this string. So this will be true, but what if we'll having with 3? So when we'll be having 3, so we can see 3 is not present in our hash map. So what it will do, it will just decrement the timestamp. So and this loop will keep on uh, executing until like the timestamp value is 0. So this will be our base case. So we can see we are having 3, we can see we are having 3 here. So it timestamp will be 2 and then it will be 1, and when it will be 1, we can get this bar here. So this is one approach, but you can see like if will be having a number such as 2 lakh something. So and so it will take a huge time. So to overcome that, we can use another approach, and instead of this hash map, we will be using a tree map. So this is the tree map approach, and everything will be same. The set, then this method will be same. It's exactly the only difference is in the implementation, and in the implementation also like this thing will also be same, which is we are checking. So in this we will be using one property for of the tree map, and uh, we can get uh, so the difference between the tree map and the hash map is like the hash map stores the elements in some random order, but like the tree map stores the values in sorted order. So what we'll be having is like we will be um so we have used this property called floor key. So it will what it will do, if we'll provide this 3 to this one, it will check the it will check the closest value to 3 in the left side. So for 3 the closest value is 1. So it will what we'll be having for this one is like in the floor we'll be having the key value, and for this one which we will get 1. If it will be sealed, then we would have been called get 3. We would have been got 4. And if we have got this one, we'll just return the value. And if we have not found, uh, it will be this one. So if we will be having this value as 2000 in the timestamp, we'll just uh, go to the left side. What's the closest value? And this will be pretty efficient for test cases like these. But there is one other approach we can use, which is using binary tree. So let's look into this. So everything will be same, just that instead of like we have taken hash map, and instead of taking a tree map here or a hash map, we'll be using a list. So in the the list, we have defined a data structure called pair, and in the pair we'll be having key and value. So the key is this one. So so this is our list with the key and the value. So, and this is our initial value, which is initial key, which is foo. So everything will be same for this one also, like you can see, instead of, but this is the difference. We, instead of adding um, to that particular hash map, we are just adding to the list. And if this is also same, like if we have, for example, if they have requested, we are having this foo data, foo map only, but if they have asked for some other which will be 2, then like it will return empty. So this, for this one, uh, if it is there, then we'll just return, and if it's not there, we'll just return empty. Otherwise we'll just return the binary search. And in the binary search, what we are providing is that we are providing this list, and we are providing a timestamp. So we are just applying binary search here to find the closest thing. So what we have done is, like, we have defined this result, which will, where we will be having that result. So let's see with the example. So for example, if they have asked us for foo 399, so for foo 399, uh, we'll search this 399 in our list. So the low will be 0, the high will be 5, then our mid will be 2. 5 plus 0 by 2 is 2. So in the 2 we'll be having 6. 6 is greater than 399. So 6 is one possible answer for our result. Then what we'll do, uh, store we'll store a result, we'll store bar 4 in the in our result, and then what we'll do, like you can see this condition, if array of mid key is greater than equal to timestamp. So this is true, so we'll just store this, the value for that one. So bar bar 4 will be entered here in this row, and we'll just increment our low. And after that, our low will be mid plus 1, which is 3. Then we'll compare, we'll find out mid again. Then next time our mid will be 3 plus 5 by 2, which is 4, and for 4 it's 500. So 1500 is uh, our next possible answer. So we'll store the result of the value, which is bar 6, in our result. And what we'll do, we'll just increment our low. So now our low will be 5 and 5. So again we'll find out the mid, and now mid will be 5, and we'll compare 4000 and 3999. So you can see it is not, like, this condition will not certify, so this will go in the else one, and will be having high as 4 now, and low as 5. So this condition will also false, and we'll just return the last answer we have stored, which is boo 6. So for this one we'll get boo 6. Sorry, for this one we'll get bar 6. So this is the last approach we are having, and all of them are pretty efficient, so you can check this one. Thank you for watching.